Okay, this is the AMA Semester 2 review, question number 1. It says perform the requested operation or operations, and this is basically a function within a function. We've got function f of x, we've got function g of x, and it says find f of g of x, which means you can see g of x is inside the f of x function, and that's what we're going to do. We're going to put g of x into the f of x. So where I see the x in the f function, I'm going to put the g of x. That's what it tells me to do. The x is now going to be 8x minus 8, and then plus 4. So this was where the x was in the f function. And just simply simplify that. We can combine negative 8 and 4, combine like terms. That's 8x minus 4. Factor what's under the radical sign. We can factor out of 4, so that's 4 times 2x minus 1. We can take the square root of 4, which is 2, but we can't take the square root of 2x minus 1, so we leave that under the radical. A little bit of radical sign there. And so our answer is 2 times the square root of 2x minus 1, which is C. Alright, for problem number 2, it says estimate graphically the local maximum and minimum of the function. And so I would graph that function on the graphing calculator and simply see what the maximum is, which would be the high point, and that's to be your y-coordinate, and any minimum values are in the y-coordinate. Okay, so when you graph the function, and I'm going to graph that, make sure that you can see the whole function. So we're going to zoom out, and you should see that you actually have a local maximum. The local maximum is at 0.1, and then you have 2 minimum values. This is where it dips down. That's called a trough, and we're really looking at the y-coordinate. So we have negative 24.9 and again negative 24.9. So that's our solution. Our local minimums and then our local maximum. Okay, so the function I have up here, this is actually problem number 3 now. We can kind of go back there and you'll see that that's problem 3, and we have some different options for our answer choice. At first glance, when I look at my function that's graphed, I think it's the answer A. But when I go back to the graph of my function, okay, so when I go back to the graph of my function, and I'm going to zoom in just a little bit here, you can see that we have an asymptote here at y or x equals negative 3. But what you don't also see is that as you come along here and you look at where x is 0, you see that there's actually a hole there, and it doesn't immediately show you. You have to kind of search along there, and it says it's undefined at 0. And the reason why is these are our x values, and so that's our domain. We usually we want to start out with the domain of our x values being all real numbers, and then we say, okay, well, what things can it not be? And so I'm going to look at some things that it can't be, and that's going to be where the denominator is equal to 0. So we say that x squared plus 3x cannot equal 0 because that's going to give us an undefined function. And I'm going to factor that. I can factor out an x, which gives me x times x plus 3 cannot equal 0, and then take each of the factors and set them not equal to 0. X cannot equal 0, and x plus 3 cannot equal 0, which leaves me with, well, x cannot equal 0, and in this case, x cannot equal negative 3. So those are our values that we don't have. So when we work our when we look at our domain, we're going from negative infinity to, here's at negative 3. We're going to stop there and then start up again at negative 3. And then we also have a value where when x is 0, there is actually a hole in that function. And so we go from negative 3 to 0 and then 0 to infinity. So the answer is actually B for number 3. Okay, for number 4, it says determine whether the graph is the graph of a function. All you're going to do is do the vertical line test for that. So if your vertical line crosses the function in more than one place, then it's not a function. If it can only ever cross in one place on the graph, then it's a function. And in this case, it's only ever going to cross one point using the vertical line test, so the answer is yes. Number 5 says find the range of the function. Range is all of our y values. Again, all I would do is graph this function and take a look at what my values of y are. So what's the lowest point to the highest point, and we'll do that here. Okay, so when I look at the graph of this function, it's a parabola. I'm going to zoom out just a little bit to make sure we've got the whole graph, which we do. And there aren't any points along here that we'll skip going from. This point is our lowest y value, so again, it's our y values. We do have a value at 4, and then it goes to infinity. So 4 is our minimum, and then we go up to infinity, which is A. Okay, number 6, we have a word problem. It says a square of side x inches is cut out of each corner of an 8 by 12 inch piece of cardboard, and the sides are folded up to form an open-topped box. You're going to use your graphing calculator to determine the dimensions of the cutout squares that will produce the box of maximum volume. So we're going to create an equation, we're going to graph that equation, and then that'll help us determine what x is, which is the square, the side of the square that we've cut out of our box. Always when you have a word problem, if you can draw a picture of it, you need to go ahead and do that. So we start out, we have a piece of cardboard. It's 8 inches by 12 inches. And we're going to cut some little squares out of it. That are x units by x units. Or x inches, I guess, by x inches. And we kind of, this little dashed line here is where we're going to fold our box up so that we have just a cardboard box with an open top on it, which will look something like this. And x is going to be our height. That's the piece that we cut out. And then we have new length and width for our box. When we took out our original piece of cardboard was 12 inches long. We cut an x from each side, so an x here and an x here, which is 2x. So that means we now have a box of length 12 minus 2x. And the same thing happens there with the width. We've had an 8-inch piece, but then we cut x out of both ends, so now we have a width of 8 minus 2x there. So the dimensions of our box are 12 minus 2x long, and the width is 8 minus 2x, and the height is x. And we're concerned about the greatest volume. So we are going to have to find the volume of our box. Volume for a box would be length times width times height, which we have. So we're going to multiply all those together. 12 minus 2x times 8 minus 2x times x. And we want to know where we have the maximum volume. So we're going to graph it. This is our f of x, which is for volume of our box. We're going to graph what we have right there. You shouldn't have to multiply it out. You should be able to put it in factored form and be able to look at the graph. So I'm going to take the function that we just created. I'm going to put that in the graphing calculator and see what we get. Okay, so I put our function that we made into the graphing calculator, and I'm just going to look at the graph of it. I do want to change my window. I have kind of something funny looking here. I'm going to, because I can see the y values, I can see the range, but the domain is kind of squished up there. I'm going to change my window for my x values and go from, let's say, -10 to, I don't go past 20 it looks like, so I'm just going to put -10 to 20, and it'll just stretch it out there and we get a better view of our graph. And I want the maximum value. The y-axis is what determines the maximum value because y is equal to our function. So I'm going to look at that local maximum, and when I click on that, the y value is my volume. My volume is 67.6. And what gives us that volume is when we cut out an x of approximately 1.6 here. So we're looking to cut out a box that's 1.6 by 1.6 inches, which is C. Okay, for number 7, this is a piecewise function, and it's literally what it sounds like. It's pieces of functions put together to make a new function, but we have some rules about that. For the first one, it's f of x equals x squared, but it says we only want the values where x is less than -1. When f of x equals 1/2, we only want the values where x is greater than or equal to -1 and less than 0. And for f of x equals 1/1 plus e to the negative x, we only want the values where x is greater than or equal to 0. So we're going to graph that and make a piecewise function. Okay, I have 3 functions in my graphing calculator, and we'll highlight the portions that we want for each one of these. But the first one, y equals x squared, this is our orange graph here. I'm not going to keep all of that function. I only want the part where x is less than -1. So I would go here, I would put an open dot where x is at -1, and then shade everything that's less than that value. So I'm only going to keep this portion of the graph. Then for the next one, we want where x for y equals 1/2 x, or excuse me, y equals 1/2, we only want the values from -1 to less than 0. So where x is greater than or equal to -1 and less than 0. So just a very small portion right here, closed dot, and then an open dot here. And then our next part of the function, the very last part, is where x, we only want the portion where x is greater than or equal to 0. So we come over here, since it can be equal to 0, we're going to put a closed dot at this point, and then keep everything to the right of that. So I'm going to highlight the parts that we need. We want, for the orange graph, I want where x is less than -1. So I would have an open dot here, and then I'm going to shade this portion of the graph. Then on the y equals 1/2, I only want the part that is from -1 but less than 0, so I would have an open dot here. And then on the 1/1 plus e to the negative x, it says values that are greater than or equal to 0. So since it's connected to the y equals 1/2 graph, I fill in this point and then continue out with the function. So the part that I have highlighted in blue would actually be the portion that I would keep in my graph. The rest of it I wouldn't want on there, only the portion that I have in blue. Which is C, graph C. All right, number 8 is kind of an easy one. We have this set of data, and it gives us in 5-year intervals the different average home values in dollars. And just, we're going to take a look. F is going to be the output values, which is literally the value, the average value of the home.